All right, we just got finished graphing cosine and sine. Now we're going to graph everything else: tangent, cotangent, secant, and cosecant. No big deal. Just watch as we go. All right, a couple things, 3 or 4 facts you need to know as we get going. The period of tangent, cotangent is pi. You know, everything else is 2 pi. Cosine and sine, we went to 2 pi. Then it started repeating itself. That was the period. Well, if you're doing tangent or cotangent, the period is just pi. We'll talk about that in class tomorrow more, but it's just pi. Secant and cosecant is 2 pi, just like sine and cosine. They're reciprocals of sine and cosine, and their period is exactly the same thing. There's 2 pi, just like sine and cosine. A few more facts here. Tangent is undefined at all the pi over 2's, which is kind of crazy. But look down here, like this graph, the pi over 2 would be up there, 3 pi over 2 would be down here. Remember, tangent is y over x. So if you put the 1 over 0 or negative 1 over 0, you have 0 in your denominator. You can't have that. So that's why tangent's undefined at pi over 2. And that's going to be a big deal. All the pi over 2's, tangent's undefined. Cotangent, on the other hand, which is reciprocal, is going to be undefined at the pi's. 0 pi, 2 pi, 1 pi, always undefined at the pi's, which is a big deal when you graph it. Okay, so keep that in mind. Tangent, undefined at pi over 2's. Cotangent, undefined at the pi's. Secant is undefined at the pi over 2's because what I drew here on my other graph, the blue graph is the cosine graph. So remember, secant is reciprocal of cosine. So wherever cosine touches the x-axis right there, that means it would be 0. The value would be 0. And if you take the reciprocal of 0, it goes on the bottom, you can't have it. So secant's undefined where cosine touches the x-axis. Cosecant is undefined where the sine graph touches the x-axis. Okay, so that's why they're undefined there, and we'll get into more of that in just a couple minutes. All right, this is what the basic general shape of the graphs look like. First, let's look at tangent. I'm going to blow this up a little bit. There's tangent. Notice what I did here, or I took a picture. I didn't really do it, but there's asymptotes at all the pi over 2's because the graph is undefined at pi over 2. Tangent of 0 is 0. That's why it crosses there. Tangent, this halfway between 0 and pi over 2 is pi over 4. Remember, tangent of pi over 4 is 1, so that's 1, and it's negative 1 down there. And the graph just goes up, 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 keeps going, down, 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 keeps going. And then it starts repeating. Remember, every pi, the period is pi, just repeats and repeats and repeats. Cotangent. Only thing different in cotangent, 2 things. One, the curve is going in a different direction. It's going down as you go left to right. Also, the asymptotes are not at pi over 2's, they're at the pi's, because that's where cotangent's undefined. It's undefined at the pi's, remember, not at the pi over 2's. Cosecant looks like this. Basically, what you could do is you could draw the sine graph. Watch this right here. Let's see if I can do this. This is live TV, by the way. If you draw a sine graph, it goes up, down, back up. It does like this. Down. It's doing this. Okay, so look at the asymptotes there. And if you look what happens in between the asymptotes, here, 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 the graph just gets flipped. Okay, it just basically flipped the sine graph to get your cosecant graph, which is how we're going to do it in just a second. And finally, the secant graph, same deal. If I were to graph cosine, I'd go like down, back up, down, back, back up. And secant, again, just reciprocal of cosine, so the graph is just flipped again. Okay, no big deal. Let's try some real ones now. First one, y equals 2 times tangent x. Okay, remember, when you see tangent, you're thinking, okay, it's got asymptotes at the pi over 2. So the first thing I'm going to do real quick is I'm going to draw some asymptotes right through the pi over 2's. There's a pi over 2, there's a pi over 2, 3 pi over 2. You could keep doing that forever. Your graph always crosses the x-axis halfway between the asymptotes. It's going to be there. It's going to cross right there. Here's the only difference. Usually I would go to pi over 4 right here and go up to 1. But because the 2 is in the front, don't forget that's a vertical stretch, about 2. So when I go halfway, I'm going to go up to 2. Same thing here, go down to negative 2. And you can connect your dots, la, 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 just like that. Same shape's going to happen here. Okay, y equals 2 tangent x. That's all you got to do. All right, so a couple tougher ones. This first one says y equals 2 tangent 2x. Okay, 2x changes the period. Remember, the period is usually pi. Well, so if I divided pi by 2, my period is now pi over 2. Here's a quicker way to do this and thinking about that way. What you can do is you can take, usually my asymptotes are negative pi over 2 and positive pi over 2. If you take the number in front of the x and divide it into here And there, it will tell you exactly where to put your asymptote. So if you do pi over 2 divided by 2, you're really multiplying by 1/2. So I'm going to put an asymptote at negative pi over 4, positive pi over 4. And by the way, key, just like last week, the key is showing me is your x-axis, is labeling. Okay, so I'm going to go up to 1 this time, down to negative 1. That's where my points are going to go. It's going to cross the x-axis here. It's be at 1 there halfway across, and boom, there it is. And of course, there's another one on the other side. You could keep on going and going. Let's try the second one. Second one's crazy. Okay, so it's got a 2 in the front. We did that a second ago. The 2 in the front is going to make my point halfway in between go up 2 instead of up 1. And the x minus pi over 4 is going to shift it right pi over 4. So usually I put a point at negative pi over 2. Okay, but it's been shifted right pi over 4. So if I'm at negative pi over 2 and I shift it right pi over 4, if I add those together, that gives me negative pi over 4. So that's where I'm going to start. And usually I would end up over here. My other asymptote would be at pi over 2. This time it's going to be at, I'm going to add pi over 4, which is going to be 3 pi over 4. But, okay, so usually I would do that right there. I'll draw my asymptotes, good to go. But that 2 right there actually cuts my period in half. So I'm still going to start here, but I'm only going to go, instead of going 1 pi away, which is what I did there, I'm going to go half a pi away. Wow, that's a lot of stuff. So, half of 1 pi is pi over 2. So if I'm at negative pi over 4, so I told you it's a lot, and I add pi over 2 to that, that's going to give me 1 pi. Let's see. Yeah, it gives me 1 pi over 4. So I'm going to change that 3 pi to 1 pi over 4. Now I can draw the asymptotes, because that was quite a bit right there. It's going to cross halfway between right there, and the graph's going to do that. All right, so we will work a lot tomorrow on figuring out exactly where your start and stop point is. And I got a good little strategy for you to do that with. And we'll talk about that more tomorrow. Okay, another one, much like the one we just did. I got to fix something first, because that 3 needs to come out of there. So what I'm going to do is I'm going to leave the 2 in front here, pull the 3 out. Now, if I factor a 3 out of pi over 2, that would become pi over 6. Because if you were to multiply 3 times pi over 6, it would give you pi over 2. Okay, so my shift is I'm shifting pi over 6 to the right. So I'm going to put pi over 6 here. That's going to be my first asymptote. Usually the asymptotes with cotangent are 0 and pi and 2 pi and all the pi's. Okay, so I'm actually going to start my graph. I'm going to put my first asymptote right here at pi over 6. My second asymptote, which usually be at 1 pi, but I got to shift it to pi over 6. That would be like 7 pi over 6. All right, but I have a 3 in the front, which what that's going to do, that's going to take my 1 pi and cut it down to pi over 3. So I'm actually only going pi over 3 from my original point. And again, I can't wait for class tomorrow. I'm going to show you a little bit of what I think is a better way to do this, but I need to show you the real way here on the video. So I'm going pi over 3 away. Pi over 3 is really 2 pi over 6. That's going to change it to 3 pi over 6, which is pi over 2 right here. So I'm going to stop at the pi over 2. Draw my other asymptote. Now, the asymptote's going to cross halfway between, and this one goes opposite, okay? So like if I got to go up to 2 this time, 2, because there's a 2 in the front. So if I go halfway over, go up to 2, down to negative 2, remember cosecant goes the opposite direction of, cotangent goes the opposite direction of tangent. So it looks like that. Gosh, guys, I almost feel like I'm sorry for teaching you that slide. I will give you a better way tomorrow, okay? Just hang in there. All right, cosecant, there's not a better way to do this one. Just stay with me here. Anytime you're doing cosecant or secant, do the reciprocal graph first. So the reciprocal of cosecant is sine. So I'm going to graph this. I'm going to graph 1/2 sine x, sine 2x. Okay, so what that means is I'm only going to go up to 1/2 and down to negative 1/2. And the 2x changes my period. Remember, period is, like we did yesterday, 2 pi divided by the number in the front, which is 2. So I'm just going to go to pi. So I'm going to go to pi, and I don't know why I put that 0 right there. I'm starting at 0. I'm starting here at 0. So because it's sine, the sine graph looks like this. Sine starts at 0, and it goes up, down, up. By the way, that's pi over 2. Now, this is why this is easy. Once you get your sine graph drawn, remember where the asymptotes go. The asymptotes go where it's undefined. It's undefined wherever the graph touches the x-axis. So I'm going to draw an asymptote there, an asymptote there. There's really one on the x-axis. Okay, so your answer, the graph of your answer is actually this right here. You flip what's in between the asymptotes. There, you're going to flip it there. You're going to flip it there. That is your cosecant graph, the green. Okay, so in your paper, you want to make that really dark or something so I know where your answer is, but that's all you do for cosecant. Okay, I want to show you one secant one, and we're done. I'm going to do the same thing here. Anytime it says secant, don't graph secant, I'm going to graph cosine. So I'm really graphing this as a cosine. A lot of stuff up there. First of all, it's been shifted pi over 2, so I'm going to start at pi over 2. I have a 2 right here, which changes the period. The period's usually 2 pi. Divide that by 2, it's 1 pi. So I'm going to stop. This fourth point right here is going to be 1 pi past pi over 2. Pi over 2, if you had 1 pi, you're really adding 2 pi over 2, which puts you at 3 pi over 2. Cosine starts at 1 right here, and it goes down and back up. That's what the cosine graph does. Now, your asymptotes for cosine will be wherever the graph touches the x-axis. Okay, so your answer will be the green you're about to see. Flip the graph in between the asymptotes right there. There's the green right there. That's secant. This part right there, that's secant. This part right there, that's secant. All right, so I really think tomorrow your cosecant and secant are going to be easier than your tangent and cotangents. But I want to tell you this. I've got a better way, I feel like, to do these, and even I showed you on here. I want you to know both ways. So I'm glad that we did this way, and hopefully tomorrow I can give you an even better way, and you're ready to roll on it. Okay, so I'll see you tomorrow. We'll work on it like always. See you then.